Welcome to screencast number 2 for Unit 6, Lesson 3. I'm on page 296. What is the life cycle of a low-mass star? The mass of a star determines the different stages that it will pass through during its life cycle. Low-mass stars, including our Sun, grow larger and become giants. Then they end their lives as objects called white dwarfs. During the active fusion stage, energy generated by fusion reactions causes an outward pressure. At the same time, gravity pulls inward towards the star's center. That's the two balanced forces that I was talking about in the previous screencast. Okay. These outward and inward forces balance each other, and the star does not get any larger or any smaller. After a star fuses all the hydrogen in its core into helium, fusion no longer takes place within the core. So the outward forces are smaller than the inward force of gravity. This causes the star's core to shrink rapidly. Basically, the star is crushing in on itself. However, a shell of fresh hydrogen surrounds the core. So there's like a little, think of an eggshell compared to the rest of the egg. Gravity compresses this hydrogen shell until temperatures within the shell become high enough for hydrogen to fuse. Okay, so the core is mostly helium, but there's this little shell of hydrogen that's left. Okay. The outward pressure from the energy of fusion in this shell is now able to overcome gravity, and so this causes the hydrogen shell to expand greatly. The star becomes much larger and brighter and is now called a giant. Giants are red because the surface temperature of the star becomes cooler as the outer shell expands. Okay. So a giant is a type of star that forms when the hydrogen shell expands rapidly. Okay. So giants are large, bright stars that have swollen up due to the expansion of that outer shell. So there's your definition. Okay, and once again, giants are either red because the surface temperature becomes cooler. Sometimes you have other giants, but anyway, most of the time they're red giants. All right, page 297. The giant loses material, leaving a white dwarf. Over time, a giant's outer gases drift away from the core. The gases appear as a cloud around a dying sun-like star. Okay. That cloud around a dying star, that's what we know as a planetary nebula. Some clouds form a simple sphere or ring, and some form more complex shapes. As the clouds disperse, gravity causes the remaining matter in the star's core to collapse inward. The core of the star becomes denser and very hot, and at this stage the star is known as a white dwarf. A white dwarf is the hot, dense core of matter that remains from the collapse of a low-mass star. Okay? Remember that what's left in the core of that star is mostly helium at this point. And all of that matter is going to be crushed in on itself even more than it was originally. So this white dwarf is going to be very, very small and dense. A white dwarf typically is about the size of Earth, meaning it's about the diameter of Earth. It's not the mass of Earth, it's a lot more massive. White dwarfs can shine for billions of years before they cool completely. As white dwarfs cool, they become fainter, and this is the final stage in the life cycle of low-mass stars. All right, so let me show you what I've got for notes on your low-mass stars. Okay, I'm back on page 296. Please remember that the mass of the star determines the different stages that it will pass through during its life cycle. Low-mass stars, which includes our Sun, grow larger and become giants, and they will end their lives as objects known as white dwarfs. Okay. During the active fusion stage, energy generated by fusion reactions causes an outward pressure, and at the same time, gravity pulls inward towards the star's center. These outward and inward forces balance each other, and the stars don't get any larger or any smaller until we run out of hydrogen and things start to change. Okay. When things start to change, go down to the bottom. The star becomes much larger and brighter because remember the core is now mostly helium and all we have left is that little hydrogen shell that swells up. So the star becomes larger and brighter and is now called a giant. Giants are red because the surface temperature of the star becomes cooler as the outer shell expands. All right, let's look at page 297. All right, over time, a giant's outer gases drift away from the core. The gases appear as a cloud around a dying sun-like star. Remember that cloud around a dying sun-like star is known as a planetary nebula. You might want to write that down. As the clouds disperse, gravity causes the remaining matter in the star's core to collapse inward. So you have basically two parts. You've got that expanding shell due to the fact that you had that hydrogen that was still fusing and expanding outward. And then you've got the rest of the star collapsing inward due to its own gravity. And the core, which is what's collapsing in on its own gravity, becomes very dense and very hot and is known as a white dwarf. Okay. A white dwarf typically has a radius about the same as the radius of the Earth, or a diameter about the same diameter of the Earth, even though a white dwarf is much, much more massive, and white dwarfs are much, much denser than Earth. Okay? A lot of the space, actually, because of the intense gravity, a lot of the actual space in atoms themselves have been squished out, so electrons are actually having to orbit in much smaller areas than they normally would. All right, so just summarized over to the right-hand side, the life cycle of stars like our Sun. So low-mass stars like our Sun will be a main sequence star for most of its life. A main sequence star is just a star that is fusing hydrogen. It's in the prime of its life, if you will. After it has depleted its hydrogen resources, it will swell up and become a giant. At this point, the core is mostly helium. And remember, you have a hydrogen shell which expands from the force of nuclear fusion. And then eventually you have the fusion of helium in the core with what's left, which is basically a white dwarf. And then that expanding outer shell of gases is the planetary nebula.